Hello everyone, welcome to Parthiba Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 31st March 2023. The problem statement for today is even swap. This problem is based on arrays and sorting. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it is said, you are given an array A and you need to generate an array B. You are allowed to apply only one type of operation on array A any number of times. In one operation, you can swap A of I and A of I plus 1 if A of I plus 1 is even. Okay, that means if two consecutive numbers are even, if summation of two consecutive numbers are even, then we can perform the swapping operation. Okay, array B should be generated after applying the above operation any number of times on array A, and array B should be lexicographically the largest among all arrays that can be generated from array A after applying the above operation any number of times. Okay, so here we can see here it is simply said that we can perform swapping operation if summation of two consecutive numbers will give even sum. Okay, and this swapping can be done any number of time if the condition is satisfied, and the final array which we will return as array B, that should be the largest one. Lexicographically the largest one, that means the way we arrange dictionary words, so that way only it has to be the largest one where each group or each swapping group which we have taken under consideration, that should follow the condition of A of I plus A of I plus 1 is even. I hope this is clear. So let's go and understand the given examples. So here n is equal to 3 and given array contains elements as 1, 3 and 5. So here the output is 5, 3, 1. So in explanation it is given that 1, 3, 5, 1, 5, 3, 3, 1, 5, 3, 5, 1 and all these are the possible values of B, while the last one is the lexicographically the largest. That means 5, 3, 1. If you visualize it as a number itself, so it is 531. So that will be the largest among all these things. This is 135, 153, 315, 351, 513 and 531. So the last one is the largest one. So we have to form the largest one. So here if you try to look into it a bit deeper, so here you can see each element at any index here, all three elements are odd. So even if you take any two pair, that means any two element in consideration, that will give an even sum. So here 1 and 3, that will give you 4, that is even. 3 and 5, that will give you 8, that which is also even. So here the swapping can be done any number of times, all the things, and we have to get the largest one. So here we can see one thing, that since all the numbers are satisfying the given condition, so and since we have to get the largest one, so why don't we just sort it and reverse it? So that is the only done here in sort. 1, 3, 5, it is sorted in reverse order. It is, so that will become 5, 3, 1. Since all the numbers in this group, we are considering 1, 3, 5 is a part of a group, so this sub-array or the group contains all the elements satisfying the given condition, so we sort them in reverse order to get 5, 3, 1. Okay, let's go to the example 2. Here it contains, n is equal to 4 and array A contains 1, 3, 4, 2. So here the output will be 3, 1, 4, 2. So here among all these combinations, we can see the last one is the largest one. Last one is the largest one, that is 3, 1, 4, 2. Largest one, that means not considering all the numbers. If that was the way, then it would be 4, 3, 2, 1. No, but we have to see each subgroup should satisfy the given condition. So here if you break down this one, so let's understand it in a better way with this example here. So first since we are looking at the example 2, first see the second one. So here it is 1, 3, 4, 2. So here if you see 1 and 3, this is the odd group, that means all the elements are odd. 4 and 2, this is the even group. That means here all the elements are even. So till the point all the elements are odd or all the elements are even, so that will tend to satisfy the given condition, because odd plus odd, that will give you even, and even plus even, that will give you even. So here we are taking odd plus odd. So here 1 and 3, that will give you even. But if you look at 3 and 4, if you add this, then 3 and 4 will give you 7, that is odd. That's why it is divided into two groups, 1 and 3 and 4 2. So that is considered as the odd group plus even group here. That means plus here, that doesn't mean that we have to add something, but it contains those two groups. So now what we are doing, we are sorting each group individually. So 1 and 3 will sort it in reverse order, that will become 3 and 1. Similarly 4 and 2, if you sort it in reverse order, this will give you 4 and 2 only. So that's why the output is 3 1 4 2. Okay, if all these elements were in one group, then we would have got 1 3 2 1, but the condition is not that way. Here the two consecutive numbers should give even. So until this condition is broken, so we can consider all the elements in one group. So here both these will give even, and separately both these will give even, but in between 3 and 4, this will not give even number. That's why two groups are here. We are sorting them independently and we are merging them. That's it. So if you look at the first example which was given here, so here all the elements are odd, so here all of them are in one group only. So we can simply sort in reverse order, that will give 531. Now let's look at some a bit complex example. So here I have taken one example, that is 14 11 18 7 10 4 20 20 18 1. So here if you see it closely, then initially after each element the parity is getting changed. This is even, this is odd. So when we have two adjacent element with different parity, so that will not satisfy the condition of a of I plus a of I plus 1 is even, because if you add 14 and 11, it will give you 25, that is odd. So here we will still be doing the same thing. Here for 14 only, we will sort it in reverse order, so that will still give you 14. For next element 11, here it will see that next element is 18. Here again the same problem, two different element, that means give you the odd one. So here in this group only 11 will be present. We will sort that group with 11 only in reverse order, that will give 11 only. Same happen for 18 and 7. So here again each group will contain one element, we sorted them in reverse order, it will give the same. But when you see from 10 to 18, here all the elements are even. So when we start from 10 and we keep on looking the when we keep on compare the two consecutive elements, and we get if two consecutive elements are of same parity, here we were checking where we got all three elements of the same parity, that means even. Here we are getting all 6 elements with the same parity, that is even. Sorry, here it was odd, all the elements were odd, here all the elements are even. So now until this parity this chain is broken, that means the next element becomes odd, till that one it will be continued getting added in one group, it will be considered as one group. So now what we'll do, this group contains 6 elements, we sort them in reverse order. So after sorting them in reverse order, we will get 20 20 18 10 and 4. And here when we go up to, when we compare 18 and 1, here again the same thing as the initial, 18 is even and 1 is odd, so again the condition will not be satisfied, so here 1 is printed as it is. So I hope this example is very clear. That means when we find something in continuous of the same parity, that means the condition will be satisfied, whether it is odd or even, the condition will be satisfied. So we keep them adding them in a group, and then we sort them in reverse order and we merge them. So here one group contained this element. In second example, two groups were there, 1 3 and 4 2. We sort them in reverse order and we merge them. This one, this one contains one group, but before that each element in one group only one element was present. That's why no change in order was there. But from 10 to 18, this was part of one group. We sorted them in reverse order. We got this, and last only was one, so one is still here. I hope all these examples are very clear. So just a minute. So here, as you can understand from the given examples, the approach what we are using here is to group the elements of the given array into sub-arrays such that sub-array contains only even or odd elements. We will then iterate through the array and group adjacent element based on their parity, whether they are odd or even. We sort each group in descending order or decreasing order, and then combine the groups to form lexicographically the largest array. I hope this is clear. So with this approach, let's start coding with this. I'll be first solving it in Java. So I have already prepared the solution just to save time in typing. Let me just copy it here. I'll explain it line by line. So here I have added comments against each line so that it becomes very easy to understand. So here we can see what we are doing in this algorithm. Here it starts by initializing previous group start index to 0, which is the starting index of the first sub-array. Then this will iterate over array element from 1 to n-1, and we check if the parity of the adjacent elements are same, then we continue to the next iteration. This is applicable in all three examples. Where it was? Yeah, here the parity used to be same in all three, so we can keep on continuing. When the last one happened, that means where the parity was not changing at all, then at last we sorted in reverse order. Here also for first two element, both happen to be in one group, so here we sort them independently and then we merge them. So okay, so what I was saying, that if the parity of the adjacent element is same, then we continue to the next iteration. Otherwise, it means that the previous group element has even and odd elements. So we sort and reverse the previous group and update the previous group start index. Once this condition is not true, that means if two consecutive elements are not of the same parity, whether it is odd or even, then we sort the array element whatever we have witnessed till now. Okay, we sort them and we reverse them, and we point current index element as the previous group start index. I hope this one is clear. So we sort it and reverse the previous group, update the previous group start index to current index, and starts a new group from there. So if we try to explain this line with this example, so here if we can see 1 and 3, these are part of one group, we sort them, and but when we are sorting this one, so it becomes as a previous group. Okay, and here I is pointing to 4, because here only we are checking that whether the elements in the previous group, whether these two elements, this and this, have different parity, different symbol. That means different parity only. That means one is odd and another one is even. When this happens, then till the previous element we have got a group which contain the same parity element. So we sort them and we will sort this point, this array, and now since I is pointing to 1, we will make the previous group start index to this one, so that we can start a new group from this location. So from there only it will continue up to last, and here we can see one group we will get and we will sort them. I hope this is clear. Then after the loop ends, there is still one group that needs to be sorted and reversed. Therefore it sorts and reverses the last group using previous group start index and n-1 indices. Finally, it returns the sorted and the reverse array. See, this extra one is doing here because when we look at this example, so here if we start from 4, then there was at no place there was a change of parity. That is 4 and 2, only 2 elements are there, both are the same parity. So that condition, the whatever we have seen here, this one, array of I and array of I minus 1, these two elements, these two are of different parity. This condition is not satisfied, that's why it is not getting sorted here. So that's why for last group we are sorting outside and reversing the same thing. I hope this example is clear, and all three examples which I have given in this problem, this all thing would be very clear to you. So now let me try, see one more thing. To reverse an array, we are using this utility method here called reverse array, and where it is using temporary variable, we simply swap the elements till the condition I less than equal to I less than j, and we keep on incrementing the value of I and decrementing the value of j after each swap. Until this condition is satisfied, we keep on swapping. So that will reverse the array after sorting. So these two operations combined will give sorting the element in reverse order. Okay, I hope this is clear. So let me try compiling this code. So here we can see we have got correct output. Let's try submitting the solution. So here we can see it has covered all the test cases. So this problem has been solved successfully. So talking about the time complexity of this solution, it is in the order of big O of n log n, where n is the order of n is the length of the input array. The main loop, the outer loop, this one, iterates over the input array once, which takes big O of n time. Inside the loop, we have a condition that checks the parity of the adjacent element, which takes big O of 1 time. If the condition is true, the loop continues without performing any operation. If the condition is false, we sort and reverse the previous group, which takes big O of g log g times, where g is the size of the previous group. Sorting the previous group takes big O of g log g time, and reversing it takes big O of g time. The worst case scenario is when the input array is already sorted in descending order, which makes the group size equal to 1, resulting in big O of n log n time complexity. Finally, we sort and reverse the last group, which takes big O of n minus g and log of n minus g time, where g is the size of the last group. Sorting the last group takes big O of n minus g log n minus g time, and reversing it takes big O of n minus g time. Therefore, the total time complexity of the solution is big O of n log n only. Okay, so this was the solution in Java. So I have prepared the corresponding solution in C++ as well. So now let's move to C++ window. Here the entire logic will be the same, only the code will be the corresponding C++, where if some inbuilt functions that can be used, so I have tried using that. So here again the logic is completely same. Initializing a variable, then we are iterating over the array, checking the parity, continuing for after that, and in else block, if the parity of the two adjacent elements are not same, then we sort the previous group, we reverse the previous group, and all these things. Okay, so here we can see with this one, here for sorting and all this is we have used the sort functionality, the sort function which is there in C++. Okay, so let me try compiling this code, C++ code. So here even this output is correct. Let me try submitting C++ solution. So here we can see even this solution is completely fine in C++. See here also it has covered all the test cases. So I'll provide the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.